Alright, everybody in their places. You guys ready on that?
Ready on that.
Ready in the blender?
Ready in the blender.
Tenfold. Go ahead and swap me the ass.
Let's get it Fracsim. Hotel wake up call got me getting up.
Today I'd like to talk about interfacing the Fracsim meter with RS-232 and RS-485. First we'll talk about the pinout. Now when you're using serial data, you're always going to be using the gator type leads on connector 1, which when you're looking at the front of the meter is on the left hand side. So RS-45 is called half duplex. It's 2-wire, and the reason they call it half duplex is because you can only communicate one direction at a time. And when you're interfacing to it with the Fracsim, you only need to hook up the 2 wires A and B. Now RS-232 is what they call full duplex, and it's a 3-wire system. The reason why they call it full duplex is because you can transmit and receive data at the same time, simultaneously. And when you're interfacing with the Fracsim, you have to hook up 3 wires, your 232RX, 232TX, and ground. And with any of these, you got to make sure to get A and B in the correct spot on RS-45, and on RS-232 you got to make sure you get the ground, RX, and TX hooked up correctly, or it's not going to work at all, or possibly you'd have gibberish and incoherent data. The good thing about RS-45 is just 2 wires, so if you have incoherent data, it's either the baud rate, possibly a connection issue, or the other possibility you just reverse it. Whereas 232, it's a 3-wire, you have a few more possibilities, but usually you can pick out ground because you can do a resistance check to the system ground, and you can usually pick out ground fairly easily. So I'm just going to go ahead and turn the Fracsim on, and I'm going to access the serial data functions, which is number 3. So first we'll go on to this first one. It says data in/terminal. So if we go in here, we get a few options there. The first one is called terminal. Terminal acts almost like hyperterminal. It's a little bit more time consuming to use than terminal, but you can basically send and receive messages just like hyperterminal. So when you press it, it's going to give you the selection for the baud rate, and I've got over here our hyperterminal is going to be on the receiving end at 19.2, so I'm just going to pick 19.2, and of course we're using RS-45. So it opens up this window here, and on the bottom you're going to see this kind of like this entry pane here, and then over here you see where it says send. So if you were to type anything on the keypad now, say I put in 1, 2, 3, 4, see it shows up right there. And if I hit the enter, it'll say message sent, and you see over here 1, 2, 3, 4 came up on the screen. I'll zoom in a bit more here so we can get a better look at what's going on. Now if you wanted to get a little bit more advanced, so say you put in another number, you can actually hit the back arrow and delete characters. Now you can also, if you hit any of the function keys, bring up the menu. Now in here you can select whether you want numeric, which is what we're on, to alphabetic, which is that T9 format. You can quick select capital Y, capital N, because those seem to be pretty common when you're interfacing with hardware. And you can select 5, which is symbols. So first I'm going to press number 2, which is alphabetic. So what happens is, anytime you press a number on the keypad, it's going to represent the T9. So for example, if I press 2, it brings up in this corner here a flashing symbol over a letter. Now if I keep pressing 2, it'll scroll through. Computer back to life there. So say if I want to type in A, so it's highlighted over A. I can just hit enter now, and you'll see that it's added A right there to the stream. Now, if I wanted to do a capital A, I would simply hit the shift key and it changes those two capitals. And I would hit enter over the A again, and it would enter the capital A there. Now when you hit send with enter, it does not actually send a carriage return. So if you wanted to insert a carriage return in there, what you would do is you go into symbols, F5, and you can actually insert a carriage return. It says enter, there's new line, spaces, commas, and escape. So I'm just going to hit a carriage return, and that shows up with the CR in there. So basically it's going to send this, plus it's going to do a carriage return. So if we look up here, our stream is 12 little a, capital A, and a carriage return. You see now the cursor's at the end there. So I'm going to hit send, and it sent the 12 big A, little a, and then it did a carriage return. Now, let's try something else. Let's just try putting in 55. Oops, I'm still on alphabetic, so I guess we're going to use K. So it entered K there. Let's try an L. Capital K and capital L. And this time, I'm going to put a new line instead of a carriage return. So KL, new line. Let's see what it does over here. So hit send. See now the cursor is down over here. Put in KL after that because it was carriage returned before, and now you see the cursor down one. And if we were to enter something here, let's put it back to numeric. If you're to enter 55, it would show up right there because we did the new line. Now receiving messages is pretty straightforward. So I'm going to go ahead and send a text file. Let's go over here so you can see what I'm doing. So send a text file. I'm going to send CSV data. So the beep indicates that it's received a chunk of data. And you can see there, it's just basically put it on the screen. Now, the Fracsim has a 500 byte buffer, which works out to 500 ASCII characters. Now what happens is, the screen tries to print as much as it can, and it uses carriage returns as well, and new lines. So if it runs out of space within that 500 characters, it'll actually save the buffer, and you can continue on to the next screen. So I'm going to demonstrate that by entering something that's going to take up a lot more room. So now I sent some WITS data. So the WITS data that was transmitted is actually much longer than this, and it says at the bottom now, enter for more. So if I hit enter, it'll show the next page, and it says enter for more, so obviously there was more. Enter for more. And there we go, there's the WITS is normally ended with 2 exclamation points. Now, the data terminal mode is not the greatest for looking at live data. If you have streaming data, what will happen is once the buffer fills up, it can't take anymore, and it won't take anymore until you finish looking through the screens. So what ends up happening is you can lose data. You don't get a live stream unless it's small enough it can print on the screen all the time. Yeah. I'm just going to demonstrate what it looks like with live data now. Close that. Yes. So it beeped, but it doesn't beep again, and it should. It's transmitting once a second. The reason it's not is because there's too many channels. So I can hit enter for more, and it's going to receive some more. And basically, it's always going to be a little bit behind. Let's see if I can pick something that has fewer channels. So this one only has 16 channels. Let's see if we can get it all in here. Now that I've cleared the buffer, you can see that it's keeping up once a second. But at any time, if you fill out that screen, it's going to pause the buffer. And widths will only accept as many channels as it is as you can fit horizontally on the screen. CSV can get a few more channels. As an example, you wouldn't be able to, this is 16 channels right now, you wouldn't be able to get 16 width channels. Now there are different serial modes that we're going to talk about that will work better for that. This data terminal, like I said, it's more designed for if you want to interface with a piece of hardware that's going to be talking back and forth, and you want to, you know, for example, if you needed to program a weight gauge in the field and you wanted to go through the yes, no, entering values, etc., you could use this mode right here. Not the specifically designed, not the greatest for looking at live serial data. So to exit this, you actually have to hit Shift Home. And let's go back in Data Terminal, and now let's talk about this mode here, widths, large text or widths. Pick 19.2 again. So this mode here, it's actually your best bet for looking at widths data. You can't transmit at all. This is receive only, but it's going to give you larger text, and it actually separates out the widths data so it's easily readable and puts it on different pages so you can sort through it. Open up Hyper Terminal again. I'm going to send some widths data. So you see, the text is a lot larger, and it shows you the channel, the number, etc., etc. It's nice big text, easy to read. You got the page indicator up here, your format, the baud rate. So if I were to hit over here, you see, just page up. You don't have to hit shift when you're in the serial mode, but if I hit page up, it's actually going to go to page 2. Now it clears the data, but on the next stream, it will repopulate the screen there. So now this is the next set of channels, 13.0113 through 0118. And if I went page up again, we should continue on with channel 119. Let's just try that. And there we go, 119 through 124, and it keeps going. So this is probably your best bet for looking at. You can look at CSV like this as well. It's a larger text, so depending on how big the stream is, you might not be able to fit it all in there. Just demonstrate by closing this and going to our CSV simulator. There's nothing on this page, so I'm going to page down, and brings to page 1. And actually 16 channels does fit all on the screen. But if you were to get any more than 16 channels, or you have more significant digits, you wouldn't be able to fit it all. The way the widths works is it picks out how many channels per page based on the number of new lines and carriage returns. And CSV only uses one new line carriage return at the end of the whole stream, not after every stream. So CSV will just all come in on one big page like this. Let's go back, look at some more options. So now, go back into data in. Let's look at the next one, small text. Now, if you were going to look at a large stream of CSV data that was too big to fit in one screen, this is probably the best option. Now, by going to smaller text, I can fit, or you can fit a lot more on the screen. So if I went to something that had 30 channels, you're going to be able to fit it all on that screen. Now, at any time, if you disconnect, the last data will freeze. So if you by chance wanted to just pick out a certain piece of data, all you have to do is disconnect your 45, it'll hold the last value, and you should be able to pick out exactly which piece of data you're looking for. The other thing to note is this right here, and the beeping. It's your basically like a keep alive. Basically every time you see it flash, it means a new stream of data has come in. Now I just want to demonstrate, if we picked the wrong baud rate, so I'll go back into small text again. Say if we picked 9600 instead, and we know it's 19.2, what's going to happen? It's just all gibberish. And the reason I put that keep alive timer is depending on how incorrect you have it set up, this might actually, nothing might not show at all. And if nothing shows at all, you'll still know data is coming in because you hear that beep once a second and you see that flasher in the corner there. So let's go in. So now there's some other selections you see here. Basically, if you continue on, there's going to give options, and these next options are customized WITS identified channels. Well, basically what happens if you pick a custom channel, for example, Interflow Blender, it basically is looking for certain WITS IDs, and it takes those numbers associated with WITS IDs, tags them with a name, and then displays the value. So I'm just going to send an example WITS file. I got to change my baud rate. This is set up for 9600. And I'm going to send that WITS file. So what it actually does is it associates the value with a tag, and these are predefined. And you can, if you're interested in having custom channels done, you can just let me know and I can enter them all for you depending on whatever your needs are. I can get it all set up for you. But this particular example, if I were to bring up the actual WITS data, so you see the first channel, 0108, is 1.2. That's not in here anywhere. It looks like the first one is 3.6. So 3.6, right there, 3.6. So what it does is it takes channel 0110, which happens to be the clean rate, and it picks out the value, which is 3.609, and it just prints it right there. So on and so forth. It just goes through the WITS, it looks for the identifier, replaces that identifier with the tag name. And this can make it, if you just want to quickly look at a unit and you just want to verify, everything's coming in on the right channel, that this works from previous use, everything lines up correctly, so you just hook it up and you can verify, yep, the clean rate is this amount, it's coming through, everything's working with this unit. So it can be handy for quickly diagnosing something. The disadvantage of this is if you have if something wrong with the unit, the baud rate's out, or maybe it's sending incorrect channels. If it sends incorrect channels, you won't see anything at all here. So if I pick a different WITS file that has different channels, I'm going to pick that one there, and I transmitted it, nothing shows up now. It's because the WITS IDs are different. So that's kind of a disadvantage because you wouldn't know. You just see basically a blank screen. So if you ever see something like that and you're in that mode, what I would do is go back in and just pick, small text or large text, and then you get an idea of what's going on. So the baud rate's 9600, 45. Let's try transmitting that again. So now you can see, instead of it being blank, all the data shows up, It's just not tagged with the name, and that way you could better identify what the problem is. Just another something to keep in mind, if it is all blank, you don't want to use that identified widths because it limits what you're actually going to see on the screen. You want it to go into one of these other modes that's going to actually show you what's actually happening. So now we're going to go into the data output. So if you hit number 2, sim data out, same as before, pick your baud rate, and we're set up at 9600 RS45, and we're just going to do widths, number 1, and I'll pick 8 channels. So it'll tell you what it's simulating at, and it also shows you on the screen what it's transmitting. And basically how it transmits is after the channel, it shows you 1. So for example, the first channel is 1, second channel is 2, third channel 3, and then the decimals are random numbers. Now again, if you want some specific channels programmed in for your company, just let me know and I can have it simulate specific channels so that you can simulate into a unit and verify everything's working with the correct channels. Same idea if you're going to do CSV format, serial data, data 9600, or oops, picked RS232. Let's try it again. Serial data or sim data 9600 RS45 CSV, and we'll do 8 channels again. And again, it shows you what it's simulating. You see it's CSV format now. And it's just random numbers. Same thing. 1 point random number for channel 1, 2 point random number for channel 2, 3 point random number for channel 3, 4 point random number. So, that way, if you're looking into your system, you can easily pick out what channel is what to make sure it's coming in the right order. And that's about it for serial data.